Here we want to evaluate the definite integral. The integral going from a lower bound of 1 to the upper bound of square root of 3 of the arc tangent of parentheses 1 over x dx. So in this problem here, we're going to let u equal the arc tangent of 1 over x, and dv is going to equal dx. So in step 2, we need to find the derivative with respect to x. So we know that the antiderivative of the arc tangent is 1 over 1 plus 1 over x squared. So the derivative of the arc tangent is 1 over 1 plus 1 over x squared. And then we need to take the derivative using the chain rule of 1 over x. And so the derivative of 1 over x is negative 1 over x squared. And then we want to find what is the antiderivative of dx. Well, the antiderivative of that is going to be x. Okay, so now in step number 3, we're going to write down the original problem. So we're going from 1 to the square root of 3. And we have the arc tangent of 1 over x dx. So using the integration by parts formula, we have u times v going from a to b minus the integral going from a to b v du. So what do we know that u is? Well, we know that u is the arc tangent of 1 over x times v, which is x, going from 1 to the square root of 3, minus going from 1 to the square root of 3. And v is x times 1 over 1 plus 1 over x squared times negative 1 over x squared, and that's dx. So let's go ahead and simplify this. So we're going to simplify this and make this a little bit clearer here. So we have x times negative 1 over x squared. And then we're multiplying that by 1 over 1 plus, well, let's square 1 over x squared, which becomes 1 squared over x squared. And so now if we distribute the x, we have negative x over x squared times 1 over 1 plus 1 over x squared. And so with that, we have now negative 1 over x times 1 over 1 plus 1 over x squared. So if we wanted to rewrite this here, we would have x. So we're going to simplify this. We're going to multiply each by x squared in the numerator, denominator. So what that means is we're going to simplify this fraction by multiplying everything by x squared. So we have negative 1 over x times x squared over x squared, and then x squared divided by x squared is going to give us plus 1. And so this x goes into that x, and we end up getting negative x over x squared plus 1. So now we can rewrite this into this statement here. So we have the arc tangent, well, let's go ahead and write the x in front of that. So we have x times the arc tangent of 1 over x and that's going from 1 to the square root of 3 minus, we have the integral going from 1 to the square root of 3, and then we determined and solved that it's negative x over x squared plus 1. So it's negative x over x squared plus 1 dx. Okay, so here we have this negative times this negative, which is going to make that a positive. So we have x times the arc tangent of 1 over x going from 1 to the square root of 3 plus 1 to the square root of 3 x over x squared plus 1 dx. Okay, so now we need to take the antiderivative of this using u substitution. So let's go ahead and take the antiderivative of that. So we have x over x squared plus 1 dx. We let u equal x squared plus 1. Du is equal to 2x dx. And then 1/2 du is going to equal x dx. So we have 1 over u times 1/2 du. Factor out the 1/2. And we want to find the antiderivative of 1 over u. And that is the natural log of the absolute value of u. And so therefore this would be 1/2 times the natural log of the absolute value of x squared plus 1. And because this is squared, we're not going to need to worry about a negative, so therefore we have 1/2 times the natural log of x squared plus 1. And so therefore that is the antiderivative. So let's go ahead and bring that back in here. So we have x times the arc tangent of 1 over x going from 1 to the square root of 3 plus 1/2 times the natural log of x squared plus 1. And factoring out the 1/2, we're going from 1 to the square root of 3. So now let's go ahead and plug this in. So we have the following. We have the square root of 3 times the arctangent. Now remember, the arctangent is the same thing as tangent inverse of 1 over the square root of 3. Minus 1 times the tangent inverse of 1 over 1, which is 1, plus 1/2 times the natural log of the square root of 3 squared plus 1 minus the natural log of 1 squared plus 1. Okay, so tangent inverse. So we want to find out what is the angle theta when tangent inverse is equal to 1 over the square root of 3. Okay, so what does that mean? That means that we want to find out what is the angle theta for when we get 1 over the square root of 3. So take a look at our angle theta, right? And so what does that mean? That means that we have y, which is 1, over x, which is the square root of 3. And so what would the hypotenuse be? Well, the hypotenuse is going to be the square root of 3 squared plus 1 squared, which is the square root of 4, which is 2. So what is angle theta? That's going to give us 1 over the square root of 3. So that angle is pi over 6. So we have the square root of 3 times pi over 6 minus, now we need to find out what is the tangent of inverse of 1. So we want to find theta, which is equal to the tangent inverse of 1, which is the same thing as what angle do we take the tangent of to get 1. Now remember, that's 1 over 1. So that means that in our triangle here, we have 1, 1, and then this is a square root of 2, so that is pi over 4. So that's minus pi over 4 plus 1/2 times the natural log of the square of square root of 3 is 3 plus 1 is 4, so that's the natural log of 4, minus the natural log of 1 plus 1, which is the natural log of 2. So our final result is going to look like the following. We have pi times the square root of 3 over 6 minus pi over 4 plus 1/2, using the properties of logarithms. This is going to be the natural log of 4 divided by 2, since that's minus. So that gives us the natural log of 2, and therefore there is our result.